This is a video for Lesson 5-6, Solving Absolute Value Inequalities. Solving absolute value inequalities is very similar to solving absolute value equations, in that we're going to be dealing with both the positive and the negative of the number. Let's recall that absolute value of x equals 3 means that the distance from x to 0 is 3 units. So x would be 3 or negative 3. If we have the absolute value of x is greater than or equal to 3, this means that the distance from x to 0 is greater than or equal to 3 units. So x could be 3, 4, 5, 6, 7, etc. Or x could also be negative 3, negative 4, negative 5, negative 6, etc. Or it could also be all those fractions and decimals in between those numbers. If we tried graphing it on a number line, let's see what happens. Okay, I'm going to put 0 in the middle. Okay, so if we tried graphing it, we know it could be 3, 4, 5, and so on. Hopefully we're realizing that means we'll be drawing this part of the number line. On the other side, negative 3, negative 4, negative 5, and so on means we'd start here and could be anything going to the left. And hopefully you realize that this looks like an OR compound inequality. If we have the absolute value of x is less than or equal to 3, this means that the distance from x to 0 is less than or equal to 3 units. So x could be 3, 2, 1, 0, negative 1, negative 2, or negative 3, and any of the decimals and fractions in between these numbers. So in this case, if we were to graph it, okay, we'd have 3, 2, 1, 0, negative 1, negative 2, negative 3, and that's it. So we would have some closed circles over here, and we draw our line to connect them in the middle. And that should look like an AND compound inequality. So when we're dealing with absolute value inequalities, it actually ends up being a compound inequality. We have to remember that a greater than or equal to 3 is going to end up being an OR. A less than or equal to 3, or just any number I should say, is going to be an AND. And you can memorize that, or if you always get stuck, come up with some examples like we did here. Think of what possible values the answer could be, and that should kind of clue you in as to what part of the number line you'd be shading in. Okay, let's move on to example 1. Solve an absolute value inequality. And I did include some helpful notes for you in case you need to go back and look at what you need to do here. Note, these still can only be solved if there is a positive number on the other side of the inequality. So if we had the absolute value of x is greater than a negative 6, can't do that because we'd be saying the distance has to be greater than a negative number. Okay, so for here, what we're going to do, first of all, since it's a greater than, we should know it's an OR. So we're going to take what's on the inside of the absolute value and set it equal to whatever number it equals. Or I should say whatever number's on the other side. That's the not bad part, because that's kind of just what it says right there. However, we then have to write OR, and we have to take care of the other side of the number line. So in this case, we're going to write the absolute, what's inside the absolute value again, but now we're going to say it's less than the negative of that number. And that's our answer. And when we graph it, we'd have an open circle at 6 with an arrow to the right, open circle at negative 6 with an arrow to the left. For part B, the absolute value of x is less than or equal to 0.5. With the less than or the less than or equal to, that's an AND. So we're going to have two numbers with it meeting in the middle. Now this one, as we know with our ANDs, is a little bit harder than the OR. Okay, but we always work from smallest to biggest. So in that case, we're going to start with the negative of this number. We're going to put less than or equal to. In this case, since it's less than or equal to there, that's the sign we are using. We're going to write what's on the inside of the absolute value, in this case, just x. We're going to put our other inequality sign. And then we're going to take the biggest it could possibly be, which is the positive of the number. So in this one here, throw my halves in there. Okay, we'd have an open circle at negative 0.5, and a closed circle at negative 0.5, what's less than or equal to. Okay, a closed circle at 0.5, and we connect them in between. Okay, flip it over. I want you to try the checkpoint. So I'm hoping you're going to pause the video on our system here. Pause the video, go ahead and try, and then when you're ready, press play. Okay, before you do these, you should decide if it's an and or an or. So in number 1, since it's a less than, we should be saying to ourselves that that is an and inequality. We're going to start with the smallest it can be. We're going to put less than whatever's on the inside of the absolute value, in this case just x. Put another less than sign, and the biggest it could possibly be. And I'm going to cheat on my number line just to save some time in this video. So I should have open circles and connect them in the middle. For number 2, a greater than is an or. So we're going to say x is greater than or equal to 8, or let's take care of the other side now. X could also be less than or equal to negative 8. Once again, cheating on my graph, but we'd have closed circles this time and arrows going in opposite directions. Example 2. Solve a slightly more complicated compound inequality, because you know they're not always going to be that quick. Okay, but we're going to use the same steps. It actually ends up being not that bad. Okay, we have absolute value of x minus 5 is greater than or equal to 7. Since it's greater than or equal to, we should be telling ourselves it's an or. So we're going to take what's on the inside and set it greater than or equal to 7. Once again, that's kind of just copying down what it says without the absolute value signs. We're going to say or. We're going to take the inside again, but now set it to less than or equal to negative 7. Now all we have to do is solve each of these little inequalities. So we get x is greater than or equal to 12, or x is less than or equal to negative 2. Okay. Once again, that is awful. That's bothering me way too much. I need to fix this. Let's see, I'll put 0 here. Okay, that's better. We're going to have a closed circle at 12, arrow to the right, closed circle at negative 2, arrow to the left. Example 3. Should say solve again. We're not writing. We're solving an even more complicated absolute value inequality. But once again, I promise, not that bad. Note, the absolute value still has to be alone on one side before you split it up. So over here, it was already alone, so we were good to go. In example 3, though, we have that plus 3 we need to take care of. So we're going to do that first. So we're going to subtract 3 from both sides. We get the absolute value of negative 4x minus 5 is less than 6. Keep in mind, if there is that number out front, we would need to divide both sides by it, but there's nothing there. Absolute values by itself, less than a positive number here, we're good to go. Since it's a less than, we should be telling ourselves it's going to be an and. So we start with the smallest it can be, which is the negative of that number. It's going to be less than negative 4x minus 5, the inside of the absolute value, which is then going to be less than the positive of the number. We need to add 5 to everything. Some of us were still making this mistake on the quiz. Whatever you do to the middle must be done to both other sides. So we get negative 1 is less than negative 4x, which is less than 11. And now if we divide everything by a negative 4, we get 1/4. Over here we get a negative 11/4. In the middle we get an x. But hopefully we realize that since we divided everything by a negative number, we need to flip those inequality signs around. And you know, with compound inequalities, especially our ands, we always rate from smallest to biggest. So I'm just going to take this inequality and reverse the whole thing. So negative 11/4 is less than x, which is less than 1/4. Okay. So I'm going to divide it up into fourths. Negative 11/4 would be negative 2 3/4, so that'll be over here. 1/4 would be right here, and we would connect in the middle. And that's it. You have 2 more checkpoint questions. Please pause the video, solve them and graph them, and then replay to see how you did. And number 3, absolute values by itself on one side. So we're going to split it up now. Since it's a greater than, it's an or. So we're going to say 2w minus 1 is greater than 11, or 2w minus 1 is less than a negative 11. We add 1. I'm just going to do it all across the board here. So 2w is greater than 12. That side 2w is less than negative 10. Divide by 2. We get w is greater than 6, or w is less than negative 5. So we'd have an open circle at 6 going to the right, open circle at negative 5 going to the left. Last one, absolute value is not alone. So first we're going to add 8. Then we're going to divide by 3. I'm going to jump over here since I don't really know if I'm going to have tons of room right there. So I'm going to start with the, first of all, it says an and. So the smallest it can be is negative 7. So negative 7 is less than or equal to 5m minus 6, which is less than or equal to positive 7. It's not really letting me go off the page. So we're going to add 6 to everything. So we get negative 1 is less than or equal to 5, which is less than or equal to, this was a 7, so 7 plus 6 is 13. Divide everything by 5. We get negative 1/5 is less than or equal to m, which is less than or equal to 13/5. So negative 1/5 is right there. So we close circle. 13/5 would be 2 3/5. And we would connect in the middle. Okay, please make sure you're writing down any questions you have. Okay, and we will work on this next class.